Welcome one and all once again to another Trotec live stream on a Friday. Very, very happy to have you all with us today. Thank you so much for joining us. Today is going to be a really, really cool stream, I think. I love these private streams because they let us talk about secrets and share stuff like pricing and all sorts of cool extra bonus tidbits that we might not be able to share on a typical stream. So I want you guys to know not only we're very happy to have all of you here with us today, but I hope you will ask us any and all questions related to Trotec and specifically about industrial marking, metal marking, that sort of thing. You toss them in the chat anytime. And we are joined by some very, very talented and knowledgeable guys today. So we are here for you guys. I'm going to give a couple minutes for some people to join. But in the meantime, I think it's the perfect opportunity to introduce my two co-hosts. Off to my side, I have James. How are you, sir? Oh, no. I think your mic is on your other. There we go.
Oh, there we go. Yeah. Best day ever. Thank you.
Absolutely. That's what I'm here for. I mean, it sure isn't my knowledge. These guys are going to keep us informed. I am going to learn, basically. What are you going to be showing us today, James? Do you want to kind of give us just a really quick kind of in a nutshell?
Behind me here is the Trotec SpeedMarker, the fantastic little beast here. It's a galvo-based fiber-lit laser. You can see inside here we've got our parts. What we're going to be doing is we're going to be marking some saw blades with some serial numbers, so showing some serialization and how easy and quickly you can get serialization on your parts. And then we're going to show a custom logo on a custom performance exhaust pipe, a muffler. So and how we're going to engrave it rotary style, but without using a rotary, with that other secret, the SpeedMarker DS or dynamic shifter, which will allow us to test around 3D surfaces without moving it. So pretty cool. I don't know if we've showed this on a live stream yet.
I think we've maybe showed a video of it working, but this is very much, I like
enough.
When you showed your hand going into the SpeedMarker, it's like showing a magic trick. It's like everything you see, there's no wires, there's no projection. It's not pre-recorded, we promise. I can show today's newspaper to the camera if that helps.
Exactly.
That's cool. Also, joining us from Ontario, Tim, how are you, sir?
Doing good. How are you guys?
Good, man. Best day ever, like you say.
No, me too.
Tim's going to be showing us some stuff more from the speedy side, I think, if I'm not mistaken.
Yeah, exactly.
Wicked.
Yeah. Yes.
I think we have a camera on your
we
laser.
Do, yeah.
We show a little bit of, I also just like the way that the stuff in Tim's machine looks, because he built, well, I don't want to steal his thunder, but Tim went the extra mile for you guys today.
Yeah, so today we're going to be using our Speedy 100 Flexx. So this means we both have a CO2 and a fiber source inside the machine. So I have made some little jigs for a bunch of plate bearings. So here's my little jig model. We got a little Trotec logo there too. So we got some plate bearings. Slid them all inside the jig. So, well, as we're playing around with the bearings, essentially we're going to be running it in a jig.
To be fair, they're supposed to be horizontal, right?
Yes.
Exactly. Nothing falls out when it's horizontal, but essentially we're going to be using this jig to help us engrave and anneal these plate bearings today.
That's wicked. Would you mind, if anybody isn't familiar necessarily with, because I mean, like when I started, I wasn't at all. Engraving, I think, is pretty, straightforward. Obviously, we're going to get to see some cool examples of it today. But if someone's not familiar with the term annealing, could you give us kind of a genuine idea or a general idea of like what that entails?
Yeah. So annealing is essentially changing the oxidized layer on top of the metal. So the way the light interferes with that layer essentially changes. So on our fiber lasers that use a MOPA source, we were able to change that oxidized layer to such an extent where we could change the way the light frequency travels through the metal and then travels to our eye. So we get a colored metal effect. So with MOPA lasers, we are able to provide an array, sort of like a rainbow array of colors. Annealing is solely for the color black. So when I mention or say annealing, that means I'm going to be engraving a black text. This doesn't mean we're going to be engraving into the actual metal. This only means that we're going to be removing and etching onto the oxidized layer of metal. So if you rub your finger along an annealed word, you're not going to feel the actual effect of the marking. You're simply just going to feel the flush metal. So yeah, as James is showing there too.
And it's still permanent in the same way that an engraving would be, right? Like, I mean that.
Yes. Yeah. I think I have one example of coloring on here,
Well,
or annealing.
I've got one here. So this end of this pipe was annealed.
Mhm.
You can see the heat effect zone here, right? Where we're at like 2600 degrees, and then it starts to cool off. So you're seeing a kind of a rainbow effect as the heat would have cooled off, and then back to the regular silver, and it's completely smooth and unetched.
Yeah, it's really cool. So I think we're going to cover the gamut today. We have the speed markers, and not just any speed marker too. I'm so glad you're getting to show off a 1300 because we very rarely get to talk about the 1300, but it's such a beautiful machine. And then, like I say, Tim is showing you kind of on the other end. Doing industrial marking doesn't necessarily mean you need an enormous machine. The Speedy 100 Flexx is a 24 by 12, but exactly like Tim said, with the two sources, you run the gamut. You're able to do a lot of stuff. I mean, we're about 10 minutes in. I know we have a lot of stuff to cover, so I think maybe let's
get her done, yeah,
gentlemen, if we're ready to go. Again, just one more reminder to anybody in chat: feel free to throw a comment in chat at any time. If we don't grab the question right away, it's probably just we're waiting for somebody to finish the thought or whatever. But we will do our best here to answer every single question you toss in chat. So glad to have you guys with us. And with no further ado, maybe James, do you want to start showing off, like you said, the beautiful beast
Sure.
that's over your shoulder?
Yeah. So I got this saw blade here. So it's just a regular old saw blade. We can show you here. I've got some graphics on there already, but what it's missing is a logo and a serial number. So let's say this particular company is they exchange blades, and so they'll sharpen the blade and then send it back. Obviously that's usually done with larger blades, but you know what? These are small, no problem. We're gonna go through a really quick program on how to put a logo on there and some really easy, quick serialization. So let's get started. First of all, I've got my jig inside the laser, and I have up on my screen, it's hard to see, but there's a yellow circle around here. And in SpeedMark, yellow is meant for a positioning graphic. And so what's meant by positioning graphic is that whenever we hit a certain key, in this case F10 or this positioning key, the speed marker is going to shoot a red dot. And if I turn the light off, it'll be kind of hard to see it's very sunny here right now, so it's quite bright, but right now you'll see a red circle going perfectly around my jig. And this is used to just lay out our job so that we can put our jig in the right place. So I use that to tape the jig down, and we can place our part inside there. I don't know, are you able to see the
Absolutely,
red light?
Yeah. You can even see
good.
the yellow on the screen. It's
Wow. Okay,
it's
so
kind of faint, but it's there.
It's my terrible eyes. Okay, so I've been staring at laser beams way too long, right? So I put this performance laser engraving because I'm a performance shop. In this instance, so all I've done is I've imported this this logo just by clicking on this PDF button and just dragging it up into my program. You see right now the program starts, it'll engrave this performance logo. This ellipse is just for our positioning graphics, and then it ends. Very boring program. If I hit go right now, it would just engrave that logo and then it would end. But what I want to do is I want to put a serial number in there. So I'm going to put some text in. So I'm going to click text, and I'm going to drop my text in underneath or after my logo. I click it there, and I'll just type in what my longest serial number is. So it's going to be like 99999. So we'll go up to 100,000 blades. And I'm going to hit add. And you'll see that 99999 comes up on here. I'm just going to resize, reposition underneath my part, something like that. I need to fill it. You'll see this, it's a lot like a CNC machine where SpeedMarker needs tool paths in order to make the laser shoot where you want it to. So you see this one has a crosshatch tool pathing, and then it engraves all around. This one here is just going to engrave all around unless I click on the filling, go to my bidirectional lines, and then maybe I want it a little darker. So I'm going to make those tool paths a little bit more dense at about 2 thou. So we want to go a little more dense than the actual logo itself. And then I need to find out what my source for this is going to be. So I don't have to type in, or I don't have to use a Excel spreadsheet if I don't want to. What I can do is I can go up to source, where the source for that text is coming from. And I can, right now it's static text, which means I just type it in and it engraves it. But I can go to serial number here, click on serial number, and right now we're at 1. Well, I'm starting at 10,001. And maybe I want some letters before it. I want maybe I want a Trotec laser performance, because I'm a performance shop. So TLP 1001. So you can add whatever format on there you want, and then it'll increment. It'll just it'll keep doing it as we go in increments of 1. And the end value is going to be 1005, and we have that. So it means essentially we're going to make 4 of these, right? So without further ado, we're going to just check: are we engraving with the right parameters for engraving? We've got our marking here as metal engraving. Perfect. We'll go to our next line, which is this outline text. Make sure that's on metal engraving. We're good to go. We're ready for action. So we just put our part in our jig like it is now. Close the door of our laser. Now, we don't have a ton of time here, but I could have programmed the opening and closing of this door. Let me get this shot down. I could have programmed the opening and closing of this door to happen automatically. So basically, I always tell everyone, if you can think it in SpeedMark, you can do it. Anything that you think a layout software and a manufacturing layout software can do, this thing can do it. And with the addition of Visual Basic, which I've now taken a course in Visual Basic just to learn how to program the SpeedMarker, you can actually integrate so many things. So without further ado, let's engrave our first part and hit go. There it goes. It's engraving. You can see some of the sparks flying off of there. It's actually ablating the metal. We're not just annealing it here. I'm actually taking metal off, because obviously this is a blade. I want that logo to last inside of there for the life of that blade. Maybe we'll get 6 or 7 sharpens out of this blade, and I want that logo to stay, because I want the customer to always come back to me. And you'll notice at the bottom was a very quick engraving of the serial number as well, and I'll show you that, the serial number. And all of this is actually ablated too. You can actually feel it. Well, you can't, but I can. So there's the serial number in there. So that's going to last, I mean, long after that ink is gone there. That is going to last on there. So now we'll throw that one. You'll see this one also says 0001. I'll put my next blade in. Now picture, if you will, a robot arm doing all this. I could have had it so that when I closed the door, it would have started the engraving automatically. So imagine a robot waiting here. The door opens, robot changes the part, door closes, it engraves. We now have a machine that is basically autonomous. It's going to keep engraving as you go. I mean, and we're just engraving on metal, so you're going all day long. You're not worrying about much. You see this next one? It says Where's the
One up.
shine? Where's the specularity? Come on.
1 out with 2.
There you go.
Yeah.
So as we go, you see, we'll continue this task of putting our blades in and hitting go. With a 21-second mark, I'm pretty happy with the way this goes. On a speedy, you know, this is not going to be 21 seconds. This is going to be more like, you know, a minute and a half, 2 minutes, perhaps, on each part. Now you see the size of that bed inside this 1300. I can load the whole bed with, instead of just one on a jig, I could load the whole bed as a pallet. And so while it's engraving all of my parts, I am filling, or I'm emptying and filling the next pallet. And as we go, you know, as it finishes, I can put the new piece in, hit go, and just keep doing that all day too. So if you don't want a robot arm, but this thing will actually control the robot arm. It will tell the robot arm to do its thing. I'm huge into having robots fill these machines. I can't wait till I get my robot arm to actually demonstrate this thing all day long. But until then, you just have to imagine robots doing this job.
Quick couple questions for you, James. So I will say, yeah, please, I mean, keep going. It's really cool to see. Some great questions from the chat, and one I have for you as well. Grogner from the chat was asking about incorporating things like barcodes, like QR codes, 2D codes, that sort of thing into an engraving like this. Is it more difficult than just adding like a text serial number? Is it?
It is not any difficulty, actually. I'll show you right now.
Okay.
So let's pretend we want to just add that, and then use the serial number, or use something. So let's put a barcode in. I click on my barcode here. I drop it into the file. I choose what kind of barcode. Let's just, we'll just use UPCA. We'll add that. So you've got your barcode text here. Add that. There's our barcode. We can rotate that 90 degrees.
Looks like you can resize that too in the same way that we are doing with the static text or the other graphics.
Exactly. And then I can even show, okay, where am I going to position this on this particular blade? So I hit my F9 key, and it will actually show. If I turn that light off, it will show it easier. Oops, not the F9 key, the F11 key, silly bear. There we go. You will see the red line there. That's exactly where it's going to engrave. Turn that light back on. I can even say what the source of that text is, and I'll go up into that source thing again, and I could go into serial number, or I could use a serial data file. And then that way, this here, serial number, will match this as well. And so if I don't want to engrave the things on there, I can just select them and deactivate them. And now if I engrave this, you'll see it engraves my barcode. Et voilà, c'est bon. Oui?
That's cool. Kind of a follow-up question to that then. I'm going to combine two questions here from the chat. I've got a great one from Bruno, and also I'm going to kind of combine it with the one from Grogdor here. So they're asking about the wattage of the machine, and so let's say this the wattage of the Speedy 100 that Tim's got there in front of him versus the 1300, and also what the focal range would be. So obviously it's going to depend on your lens that you have installed, but they kind of go hand in hand a little bit. Wattage and lens size. Right. I assume that's to do with the type of jobs you think you're going to be doing.
Yeah. So the first question, the difference in the wattage, I imagine Tim's is probably a 30 watt, a 20 or a 30 watt.
Yep.
And this one here in the 1300 is a 100 watt, the 100 watt MOPA. And so the big deal with the 100 watt MOPA, two big deals. One is that it can anneal really quickly. So annealing slow, because we have to create that heat effect zone to heat the metal up to the certain temperature in order to create that oxidized layer that Tim was talking about. And so faster you can get it up to heat, the faster you're able to go. And so 100 watt allows you to do that really easily. The other thing 100 watt allows you to do is do deep engraving really quickly. So you're actually ablating the metal, you're engraving it, you're taking away metal. The other thing that a 100 watt does well is it turns clear anodizing black a lot faster, because you need a lot of heat to do that. So 3 really great reasons to get a higher powered MOPA. There's some deep engraving there. Laser Dave. And so yeah, I have 100 watt. And then focal length, I have a 254, an f254 lens in there. And I would say my focal length is about 14, 15 inches. Whereas with Tim's, it's probably 3.2 inches, I would imagine he's using.
2.85.
Oh, you're using the Flexx lens.
Yeah.
As opposed to the fiber lens. Cool.
Yeah.
And so yeah, so that a lot more focal length with this one, which allows a lot more sort of depth of field. There's a longer focal distance that sort of stays in focus. The 254 also allows for just a lot of variances in material as well, but gives you a little bigger spot size than you would get from, say, a 3.2.
Well, and following on from that too, so Bruno does ask if that's Ruby there, the software you're showing. But really quickly, you mentioned about the darkness of the engraving and that sort of thing. So he asks, obviously the contrast is really good in the high carbon steel.
Mm-hmm.
How would it be on, say, aluminum or even other metals, obviously, right?
I mean the every metal reacts a little differently. So without the carbon content, you don't get a lot of darkness. So on plain old aluminum, you don't get a lot of contrast. There's enough contrast to read for sure, but if you want to use like clear anodizing, so silver anodizing, a MOPA laser will be able to turn that black, and 100 watt will actually be able to do it in a speed that is actually okay for manufacturing. Aluminum's doesn't go as dark as the carbon steel. Like if you do like a knife or maybe one of these CNC blades here, they'll go really black because they're filled with carbon. These cheaper saw blades here, not quite as filled with carbon, but still dark enough that they're going to stay contrasty longer.
Awesome. Well, so I'm going to come back to Bruno for you. I'm going to come back to your question about the software because Tim is going to show us some Ruby software. But I wanted to quickly have James do some stuff with the muffler, if possible, that you were talking about, because I think
sure,
that's a really cool. But please, obviously, if you guys have some more questions about anything we've been talking about, again, by all means, please toss them in.
Yeah. So with this muffler, in the past, what we've been doing is we've been attaching this muffler to a rotary tool, and so that rotary tool would take this muffler and it would spin it, and as it spins, it's going to engrave back and forth, back and forth, back and forth, and that tends to get slow on parts. If you had 10,000 of these parts and you had to put each one on a rotary, it would work. Of course, it's going to work great, but it's not going to be fast, especially on fiber too. With fiber on rotary, you got to make sure that your focus is perfect, and it's not sort of angled any way. There's a lot of factors that go into that, and so what we've done is designed this dynamic shifter in this machine so that you don't need to move the part anymore. The laser just knows. So I'm going to show you how it knows, and I'm not just going to do it straight. I'm going to do it on a crazy angle too. So if you want to switch that camera over to my SpeedMarker here.
I will say, I love rotary engraving. There's a lot, particularly these days. Pardon me. There's a lot of work that's being done with rotary engraving with, bottles, all sorts of different items. But I would say one of the limits with the rotary tool, as much as I love them, is they are kind of one at a time traditionally, right? You kind of have
certainly are.
One in, one out, one in, one out.
So, if I had a whole bed full of these mufflers, we could be we could be showing you how we could do a whole bunch of them at a time. And of course, the robots are moving the parts back and forth. So just to make it easy and quick, I've put little pieces of tape with a little mark showing where top dead center is on my part. So this is a 4-inch muffler. It's polished stainless, and I'm going to use a polish setting on the laser to produce kind of a silvery kind of a white silvery mark, as opposed to, you know, the dark deep engraved mark that I had before. So what I'm going to do is I'm going to tell the SpeedMarker where top dead center is, where the position is, and what the diameter of my part is, and it's going to come up with a 3D model of that part. So watch this. I'm going to go to my SpeedMark software now. So let's destroy this barcode. Let's reactivate our logo. We can delete that text as well, and that ellipse. So there we have our Trotec Performance. Let's make that about 2.5 inches wide, and let's put it on a jaunty angle, just because I'm just screwing things up left and right here. I've got the actual part on a weird angle. I also have my logo on a weird angle. Now
it's a performance shop.
Exactly. We're trying to be cool for the kids, right?
Yep.
So what I'm going to do is I'm going to go into 3D projection, and I'm going to enter a new 3D object. So it most represents a cylinder. So I'm going to select the cylinder, the outside of a cylinder as opposed to the inside of a cylinder. You can do both. So I'm going to select that, and it's going to say, I want this position first. Well, no, let's put this position here in. This is my bottom position. My bottom position, and you'll see on our in the actual laser itself that the red dot is sitting on my top dead center in the actual laser. So I'm going to hit apply to current axis position, and now I'm going to move physically the SpeedMarker, the actual head of the SpeedMarker, to my new position. As we first stay with the new fingers here.
Gotta get that robot arm, like you said.
I know, robots. Robots. In the future, there will be robots. If you guys want to see robots on the live stream, just put it in the comments. Say, hey, Trotec, get James a robot so we can know how to use them. Okay, so I've got my red dot on the second dot here now. So now I'm on this dot. I apply to the current position, and I tell it it's a 4-inch diameter. I hit OK, and look what comes up. It actually shows the 3D object in my screen. It shows how it's going to look inside there. You can actually get a good sense of how it's going to look. Now, look at the wrap on that. It's pretty awesome. It's not something you could do with a flat SpeedMarker or a Speedy. But look,
Yep.
as I move this Trotec Performance, you'll see it moving on there. I can even rotate this around as well.
Well, and to your point from before, if you had 6 of these mufflers side to side, it would just be a matter of putting 6 cylinders side by side by side, right?
Building jigs for each of them, right? For some reason, it doesn't want me to spin it. You know, I can, as I move this around, you'll see it's spinning on the actual part. If I kept it straight, you'd see it would go straight across. So let's go negative 30, negative 30 again. And you'll see that there it is right across at maximum angle. But I like it at a jaunty angle because we're a performance shop, as you said.
Exactly.
Looks pretty awesome. Then I'm going to make sure I put my fill in there. And I'm not going to use cross lines on this one, but just parallel lines. And I want it to look really cool, so I want those lines to go up and down. Right now, as you can see on the screen, they're going side to side. I want them going up and down. You can see I've changed those to up and down. It just the way you change those fill patterns has a difference on how the actual engraving looks. Then I'm going to change the actual marking profile from steel engraving to something like an anodized aluminum, just a really light, fast engraving, because I want that silvery look. So I could optimize that setting and have it just perfect for this steel, so it would go white, white, white. But I really liked the look of this nice silver, so I would just probably save this as, you know, chrome white, and we'll keep that as anodized aluminum. So you see, I haven't really done much in my program here. I just have that. So now it's time to close our door and run the program. It's just as easy as that. Here we go, folks. It's almost so easy it's not even cool.
I think it's cool.
It's cool. Trust me, it's cool.
I'm just marveling at like the amount of depth that you can get there without having to rotate. Like the fact that you have the focal depth there. I guess it would be that logo is in focus all the way around, despite the fact that it clearly wraps around the object.
It clearly does wrap around. Like it very much wraps around. Check that out, eh?
This is gorgeous.
Here, let's bring it into the light.
Yes. That's nice. That's beautiful.
And it's clear all around too. Hold on, sorry, I'm just trying to get it. Come on, phone. There we go.
Ooh.
Right around, and that is a pretty wicked angle we got there. That's pretty much. It's not the full extent of what we can do, but it's quite a wrap, and it was so fast. Like I work a lot with rotaries, and to see this happen makes me cry. With, you know, all the 25 years I've been doing this and using rotaries, it makes me cry. The time, the 3.5 minutes to engrave this, and the 20 minutes of setup, then engraving on tape to make sure it's perfect. And there's so much. Watching this is like a dream come true for someone who's been in the industry for so long. Just to have this just work perfectly, and like I was explaining what I was doing, so when I was doing my tests, I didn't need to explain. It was just like it took literally 2 minutes to set this job up.
Well, but even what you showed, I mean, it's not like it was complex. I mean, you selected the 3D object. It's most like a cylinder out of the 3 objects.
Yeah.
You put in points that you would have had to put in, you know, even if you had, like, you'd have to get the diameter if you're using a rotary or not. So that's a moot point, right? That you have to do either way.
Yeah.
And then realistically, when it comes to finding the top and bottom point, when you're positioning your graphic on a rotary, you're doing something very similar regardless. So, I mean,
yeah, where I think this technology is going to is that imagine importing a step file of your part that you've, and for the people who don't know what a step file is, it's a 3D machining program file. So, you know, you go into your 3D software, take the part that you've just machined and got anodized, let's say, you enter that step file into the SpeedMark software, place your art on it, and the SpeedMarker goes to town. That's where I think it's going. Nobody's ever said this, but I can imagine that this is where the technology is going to head. And it's just a matter of the programming, really. So, I mean, right now we have all the basic shapes. We can do inclined planes and spheres and bowls and balls and cylinders, inside cylinders. So what's next after that, right?
I think what's next after that is that I'm going to toss over to Tim.
Yes, good idea.
I mean, that is really cool, James. Thank you. Bearing in mind, so you guys, if you see anything today that you think is really, really cool, and you are in Ontario, Montreal in my case, British Columbia in James's case, and you'd like to see it in person,
or Alberta,
we'd love to, absolutely, in Alberta. Unfortunately, Renee isn't here with us today, but we'll have him in soon enough, I think. We would love to have you guys out to the show. Bring your mufflers. You know, bring your don't bring your catalytic converters, but bring your cylindrical objects. I think there is something very special about this software. I think getting to see it in person is even better than getting to see it in video. So if you thought that was really cool, I invite you to come down and check it out with James in person. Do the inside of your cylinders. I mean, we would love to have you guys out, but I'm going to toss over to Tim, and I wanted to come back to this question that Bruno asked earlier on. I believe it was Bruno who was asking about whether it was the Ruby software that James was showing. as James just mentioned, he was going through SpeedMark, but we're going to have Tim kind of run us through some of the same cool type of techniques, but using Ruby, if I'm not mistaken.
Right. So I'm using Ruby. With full disclosure, Ruby will be available on the SpeedMarker machines at a much later date that we're not really sure about. The idea is to bring all of our machines back onto Ruby software, but that of course takes some time, and the machine's programming and languages are a bit different, so it's going to take some time to get all the machines on there. But for the meantime, all of our Speedy Lines machines, they use Ruby. So today I'm going to be showing how to use our Speedy 100 Flexx here to engrave on some metal plate bearings. So these are stainless steel plate bearings here. The jig that I've made is just made of 2 pieces of acrylic. The white one has a piece of 3M on the back, so I glued it right onto the red coating underneath. Cute little Trotec logo there as well. Yeah. And the general idea is that right here, the file that you see is the file that I made in my Adobe Illustrator. So that means I have placed all the red cut lines. I have already placed the areas that I want to engrave with black text and black vectors. So all I have to do is import the file into Ruby and just disable and enable layers, whichever ones I want to engrave and cut. So I can essentially do this all in one go. So I made a 2-layer jig so I could just easily take out pieces. But hypothetically, if I wanted to simply just engrave and cut this piece out, leave it in the machine, put the plate bearings in, I'd be able to just turn off the cuts, enable the engraving, and have it go straight from there. So in this case, I'm going to be working with some large plate bearings. I also have 2 more jigs for some medium-sized and small ones as well, so we could run multiple types of bearings here. So right now, I'm just going to place the jig into the machine, and you can see I'm just going to line it up with the very top left corner of my machine. Right now in the software as well, I've lined up my file in the top left corner as well. As I mentioned before, the file that I've made, this is exactly how the file will look like in Adobe Illustrator. So this file that I've made has red cut lines. It has black areas for engraving. So if I just quickly enable the red, you can see that this is how I've made the file. So I essentially took these plate bearings. I made sure to measure them out efficiently so that each and every single one of them would fit in with little to no tolerance. So they just simply slide into position.
I won't lie, it is very satisfying watching you drop those in there.
It is extremely satisfying.
It's a bubble wrap effect. I can't lie.
They neatly slot in. So bearings all in position. The file that I've made in Illustrator is exactly a copy of this file in the machine. So the file that's right now in Ruby, you can see here, I've lined it up with the top left corner of my machine. I've done some previous testing beforehand too to make sure that everything does align correctly. So I found that with my jig placement, I may have glued one top over another in an incorrect way. So I had to adjust it by 0.03 negative Y axis. So the jig in the software is just up by 0.03 on the Y. Very small adjustment needed. So that means in terms of how I made this jig, it was nearly perfect. I was within 0.03 inches of making this a perfect jig. So it's nearly there. So now the general idea here is essentially when I turn on the machine and I allow it to engrave, the areas that are labeled with the Trotec logo and a barcode, they're going to engrave in the exact same positions that I have these bearings placed because the jig itself is representing this file here. So all I have to do in Ruby after I've imported this design file onto my prepare screen, which is our laser bed, I'm going to just quickly head over to our material section, which is just in this area here. I'm going to click on the red square. I'm going to unassign that layer, and I'm going to leave only the black options turned on, meaning the machine is only going to run the black engraving and nothing with the red line itself. So I could also quickly open up my settings in here to just make sure that I have the correct settings for my stainless steel engraving. I took these settings directly from our own material library. So with Ruby, with SpeedMark, we always provide some sort of material settings. So in here, I have engraving settings. I also have some nice annealing settings too, so we could play around with some stainless steel annealing too. I also have my fiber laser source selected. All my settings here look correct. So I'm just going to close off this layer, and I'm ready to send this off to the machine. I've already focused the laser as well, so everything is nice and focused. And I'm just going to press press on this button here, push the laser. So now I get a nice little preview of my screen here. If I click on this little page here, I can see a nice zoom in of what the machine's going to be doing, so I can already tell it's only going to be running the blacks. I also have the name of the file, I have the name of the material, I have my power and speed settings on the side here as well. One cool thing, we could also head back to the prepare screen. We could just quickly run a time estimate by clicking the calculate job time button. It's going to give us a quick estimate. We have 1 minute and 22 seconds for this job right here, and we're going to get that estimate right below here as well. So now I'm just going to close the lid of the machine. I'm going to quickly enable the exhaust, and I am simply going to press play on the page here. I'm going to wait for the machine to initialize, and we're going to have it run our engraving.
I think one thing that's really cool too, and I wanted to mention this because Bruno asked about when will CO2 laser be available on the Flexx machines, or what entails a Flexx machine. Tim, as you were saying, it's a machine that has both sources in the same machine. Yep. So technically you were able to create the jig and now do the marking of the pieces in the jig all on the Speedy 100, right? I mean,
exactly. Yeah, in theory, if I didn't want to have the red backing panel on these jigs and I only wanted the white, all I would do is put a piece of white acrylic into the machine. I would remove or turn off the black layer. I would enable an acrylic material setting. I'd have only the red lines enabled, and it would just simply run all of the red lines, cut everything out. And I can essentially just take off all the excess white material, leave that in there, throw the bearings in, change the material setting over to stainless steel, turn off all the red lines, enable all the black engraving, and the machine will go from there. So that's awesome. We could essentially just leave everything in the machine. The only thing that we need to do differently is simply just adjust the focus on the laser to adjust for the different heights. And that's just about it.
Can I ask what I love about this is if somebody were watching this that already has a Speedy and is thinking, is it possible to get into kind of the industrial marking side? I mean, what I love about you demonstrating is, on a Speedy machine is that you could upgrade your current Speedy to a Flexx machine by adding the fiber source, right? I want to ask you though, in terms of, I think you're showing it really well, but also just in terms of, doing a different kind of marking or using the fiber source in Ruby, is it any more difficult than doing anything with CO2? Or, I mean, it's all the same workflow, right? I mean, regardless of what source you're using, what you're doing.
Yeah. So it's more or less going to be the same workflow as well. If I wanted to, instead of marking this with a fiber, if I wanted to see what a CO2 would do, I would simply go into the settings in Ruby. I would change the source to CO2. It won't do much on metal, but I can change it to CO2. So if I had an application that had, for example, a knife with a wooden handle but a metal blade, and I wanted to engrave the metal, engrave the wood, instead of running 2 separate jobs, what I'd be able to do is assign 2 different colors to do 2 different layers, assign 1 layer as a CO2 and 1 layer as a fiber. So the machine would interchangeably use the CO2 to complete one part of the job and fiber to do the other. Now, that being said, the machine does use a special lens called the Flexx lens. If we have 2 sources in our machine, it's going to come with a Flexx lens, meaning we could use both CO2 and fiber source. We don't have to interchangeably change the lenses. If we have, for example, in our machine, only a CO2 lens, we just can't use a fiber source through there. That's how we damage lenses. So with the Flexx lens, that allows us to run one job with 2 sources in 2 different areas of the same bed.
I will say too, so there's a question in the chat about how it's run, but just to make it very, very clear, so it is actually 2 separate tubes in the same machine. Do they run by the same optical path? Do we know, or are they? Is there a beam splitter inside the machine? Do they?
It does. So they all are going to run through a beam splitter or like a mirror that will combine both beams. They do come from 2 separate areas. So for a Speedy 100, the fiber source is right below the CO2 tube. For the Speedy 300, it's going to be the same principle. It's just below the CO2 tube. Cool. For the 360 and the 400, they're both, the fiber is going to be on the right side panel. The CO2 is going to be behind the machine.
Awesome. That's wicked, man. Can do you want to show off one of the bearings? I'd love to see it up close to the.
Of course.
Quick question for James, just while you're grabbing it, because it came here in the back end. I think it's a good question. If someone was thinking about, doing an upgrade or bringing this sort of marking in as opposed to maybe outsourcing it, like what would be the reason that doing it in-house would be beneficial as opposed to necessarily having somebody else do the bearings for you, or, if you are that company that sharpens saw blades, like why bring the marking and the serialization in-house as opposed to, sending it out? That does look nice, Tim.
Oh, sorry, you're asking me? Or sorry, I was just distracted by cleaning.
I was gonna ask James. No, I'm sorry. I think we've got the wrong. We need his. Yes, that's the one.
Hello, can you hear me now?
Yes, sir.
Okay. Well, yeah. The bringing the marking in house. I mean, it's very difficult to find somebody who will actually get your jobs done quickly. With a fiber laser. That I know around here, there's a sincere lack of fiber job shops who can do this, and so a lot of people are bringing it in, and even those fiber job shops, as amazing as they are very busy. So with lead times of materials being so long, the last thing you need is another 2 weeks to get your engraving done. And so I'm hearing from customers, oh, it's taking 2 weeks, it's taking 3 weeks to get anodized parts engraved. And so it's like, wow, okay, well, you need to have it in house. And some people are like, well, it doesn't make good business sense on a monetary scale to get this done unless you put in the fact that I can actually get it done and not have my products late for market. And so we're finding people with a lot less parts needed than we would like to see buying machines, because they are able to get their parts out same day that they're produced. They get produced, anodized, engraved immediately, not having to have that 1 or 2 week lead time, and out the door immediately. And then they are in control of the quality of the engraving. They're in control of the marking. So that's a reason to have this kind of marking in house.
That's a big one too. Like you say, being able to control that. I mean, you control the quality very carefully in every other process you do with your product, and it's scary then just at the last step to send it out of your, out to somebody else who, I mean, who knows, right?
Yeah.
I will ask Tim.
2 weeks. It took 2 weeks, and then it takes another 2 weeks to get it right.
Oh man, that's a nightmare. I will ask Tim that the engraving you just did was ablated, right? It was like James's engraving. It was literally cut into the metal. We didn't get to talk about it when you showed up to the camera, but it looked really, looked really nice.
Yeah, here, let me get it for you. I think this camera might be able to pick it up a bit better.
Yes.
Yeah.
That looks good, man.
Yeah. Another cool thing about the jig is while I was placing everything inside the jig, I was able to just scrub down without having to move anything. So it's a nice and efficient way of cleaning. Just used a little cloth. There's going to be residue, of course, on the metal, but just quick little clean through.
It's more like dust than residue. Like residue sort of stinks of stickiness and yuckiness, but it really is just dust.
Yeah. So now I'm just setting up the plate to try to run an annealing.
Yes.
So I have the medium bearings set up in Ruby. I'm going to open up the material tab on the right, and there's going to be another material drop down. I'm just going to click on that quickly, and I'm going to search up annealing, and I misspelled that.
Just because you are an engraver, don't mean you can spell it.
Yes, I was going to say, I'm just glad it's you searching it, because I couldn't spell it to save my life.
I think I spelled it correctly. It just seems like someone removed the letter G in annealing in the settings here.
It's the cooler bird, it's annealing.
Yeah, we're annealing.
Yeah, so we can see here the difference in settings that we have for annealing and engraving is the speed and our Z offset. So we're going to be lowering the table a bit by 0.8 inches. So that's going to give us a bit of a better annealing effect. We're going to see our text with a bit more contrast to the metal as opposed to engraved into the metal. So I'm just going to save this file off. I'm going to run an estimate for the job time. I'm going to see 2 minutes. That makes sense since we've slowed down our machine. I'm going to press push laser, close that lid off, and I'm going to press play.
Sweet. We have that question pop up there in the chat, and just while we're waiting for the annealing, I wanted to come back to it. I mean, within reason, James, are you able to share with us some of the, because I think, I mean, you touched on how let's say some of the shops that might do fiber engraving in particular, like outsourced fiber engraving, might be very, very busy. I would assume then that they might also be very expensive. I mean, if your product's in demand, certainly I would charge a reasonable price for it. So, I mean, you stand to save some money by bringing engraving in-house as well, I assume, over time.
You definitely do. I mean, if you're only engraving, 7 parts a week, no, you're not going to save money with the actual engraving. You're going to save money because you won't be docked for having a late shipment, or you won't miss a shipment and then have to be docked by the shipping company. But as your part demand goes up and up, there becomes a sweet spot, and that's where calling your local Trotec rep like myself, who knows the inner workings of the laser and the ROIs and the how much setup is involved with things, sitting down with me and talking about, let's look at an ROI for me getting a fiber lead laser. I have 10,000 parts a month that I need marked. Does that now make sense? And yes, that does absolutely make sense. And it's I can't put this is the exact amount you will save by having it in-house, but when your local fiber job shop's going to be charging $150 an hour to operate this machinery, because it is so darn fast, they're making bundles of money. And you're spending bundles of money. So, if you kind of look at how long it's going to take you, times that by $150, and then you have like the setup charge and all this. Mm-hmm. That's where you kind of have to look at, does it make sense to get one or not? And then, you talk to me and say, well, how much is it to lease one of these machines? Is the amount I'm paying per month more than it is to lease it per month? Now we can talk. Now that we're looking at a good business case for that, and depending on how much higher above that lease price your outsourcing bill is, more and more and more money is going to be saved. So without saying a specific number, because that's impossible, on a case per case basis, that's how you can kind of look at, will it pay me to have one of these in-house?
Absolutely. And I mean, look, if it's something that you're doing in-house that allows you to further customize the piece you're doing for your customer, I mean, if it's not even just serialization, but there's also the opportunity to, if your customer needs their logo on a piece or whatever it might be, right? That's something that you can then also charge a premium for, hypothetically, if you're on that more like manufacturing side, whatever it might be. But as James said, it's possible to take a number because it varies with each customer, but at the same time, certainly something to consider. I heard the laser go.
I did too. I heard
I'm
that
eager
beep.
to see.
I hear that beep in my sleep.
I can't pretend I'm not.
All right. So with annealing, this is the result. Oh, and that bearing went flying. Give me 1 second. So this is the annealing result. You can see it's flush with the metal, so it doesn't get marked. And this is the marking result. So the annealing, we can see it glosses, shines with the actual metal, so we know it's not marked into the metal.
It keeps the specularity in place of the metal. Yeah,
exactly. And with the marking, we could see sort of like, it's like orangish hue almost to it. It's like a yellow hue, yellow tint. Doesn't look bad, but I like the way the annealing finishes on it because it gives a much better contrast on the stainless steel. So it looks much more, it just looks crisp. Mm-hmm. The marking one's not bad, but I like annealing a bit better.
Well, and I assume there are some projects too where marking might not be possible. I mean, if we don't want to actually have, any sort of indentation into the metal, I'm thinking of, some food service industries or things like this, where if you're working with any sort of, machine that needs to handle food or just can't accumulate bacteria in any way, then annealing is a great opportunity to still get that permanent, marking, but not have to worry about, creating divots or changes in the actual structure of the metal itself. Mm-hmm. They both look great, man. Yeah, and not much of a change in time either to do the annealing. It was 30 seconds longer, but
yeah. I mean, so we got the marking bearing and the annealed one here. See, the detail in the annealing just comes out a bit crisper. See the barcode. That was barcode. I didn't actually serialize. That was just made with vector rectangles. I was trying to get very, very thin lines to come through on there. Trotec logo is more or less the same size on both bearings, but they come through both very, very differently.
Nice. That's a good point to make too, Tim. I think I mean, you said it when you first started that eventually Ruby will be coming to the SpeedMarker machines, absolutely. But in terms of actual set serialization that's either pulling from, an Excel file or something like that, at the moment we would have to do it using the SpeedMark software like James showed. That's kind of more of the easy, you can set that up. I mean, you showed us, James, it looked pretty simple to kind of set up that automatic serialization.
Yeah, with the SpeedMarker, it's as easy as you want or as complicated as you want. It's like it doesn't matter. I have a customer who has set it up so that like it controls the robots feeding it. It controls the data for the other manufacturing machines for this particular product. It controls, it sends for a serial number from a different country, a secure tunnel. The SpeedMarker software does all that, and it's the hub of the entire marking center for this really, really secure marking protocol that they have. And then I have a jeweler who just doesn't program at all. They place their vector art and they select a profile and hit go. So it's as easy as you possibly want, and it's as complicated as you possibly want. And that's what I love about the SpeedMarker, is it just, like, as I said, you can do anything with it. And that Ruby's coming to the SpeedMarker is great, because then that puts another layer of how easy it is to use to the SpeedMarker. I imagine they'll still keep the SpeedMark software, or they'll move all the features of the SpeedMark software to Ruby, which would be incredible for the Speedies if they did that. Obviously, we're not privy to this information, but gosh, I keep crossing my fingers and hoping that if they're bringing Ruby to the SpeedMarker, can they bring SpeedMark to the Speedies? Would be incredible.
Agreed. Yeah, fingers crossed. Either way, I mean, it's a win-win.
We don't know.
Yeah,
it's a win-win. The guys with the boots on the ground, we don't know this stuff. So when we know, you'll know.
Exactly. We'll have another of these webinars with the secret information in the back end.
That's right.
I wanted to quickly touch on, Grogdor asked if there was availability of a MOPA source on a Flexx machine, so a Speedy machine. But the MOPAs are exclusively to the SpeedMarkers, unless I'm mistaken.
Yes.
Yes.
Right.
Okay. Perfect.
Yeah. Right now they are. There was talk of it, and I have several customers who are waiting in the wings for the MOPA to show up on the Speedy, but for now, no.
I was gonna say, I got a little note from, and a huge thank you to Lev in the background who's doing the producing.
Thanks,
he's popping
man.
up all the videos and everything for us, swapping the cameras. He and I are on the same wavelength, because we were just wondering about, speaking of, we may not be able to bring the MOPA to the CO2 or those machines. We've kind of brought the CO2 to the SpeedMarker side. I think next month we're going to be talking about, if all goes well, our new CL machine, which we've kind of demoed a little bit here and there. But I mean, James, do you want to kind of give us a very kind of, in a nutshell, is it possible to talk a little bit about what makes the CL cool as a machine in general?
Now, like, if I wanted to do wood, or if I wanted to do acrylic in this beast here, it wouldn't do a very good job. Especially acrylic, it's going to shoot right through it. It sees clear objects just like we do.
Because it's a fiber laser.
Yeah.
To make it clear,
so with a CO2 laser, we'll be able to engrave wood with it. You can kind of engrave wood with the fiber, but it's spotty, and I wouldn't recommend it. But there are things you can do with this, with the CO2 galvo, that you can't do with the fiber, like fabric. Does it do a fantastic job on fabric? Absolutely. On wood, on acrylic, and fast, because we only, like, a Speedy has to move your this whole gantry, many hundreds of grams of metal around. With a galvo, you're flicking 2 mirrors just this much, and you can produce a foot long cut. So imagine being able to cut fabric so fast. Like, you put a 100 watt or a 200 watt CO2 into a galvo, and now we have the precision of the galvo with the speed of the galvo, but with the actual cutting power of the CO2 on materials that the fiber just can't touch. And that's what I'm really excited about. I'm getting mine at some point, maybe this month or next month. So I'm super excited to show everybody.
Agreed. We have some videos of, and Lev is just going to show us a couple of them now, of the original CL. This is kind of a new, up-to-date, kind of new and improved even version of it that's going to be even cooler than the previous one. I'm excited. I don't want to show you guys too much because it is incredible. But the speed that you saw James marking, the saw blades with at the beginning of the stream there, just imagine that with the CO2.
Yes, exactly.
Let your imagination run with you for the next month, and then we'll come back and we'll show you all the cool things.
I can't wait.
If there are any more questions in chat, we're happy to take them. But I think for the most part, we're just hit the hour here, so I am going to we'll maybe start wrapping it up. I want to say thanks again to everybody who's joined us in chat today. Thank you for all the great questions from Bruno, from Grogdor, from Travis. Thank you for stopping in, man. Obviously, a huge thank you to both James and Tim, not only for showing us all this cool stuff today, but for preparing all this stuff in advance for us. I mean, couldn't do it without you guys, very obviously, as I stand in my white shirt in my white room. Again, I want to mention, if you are anywhere in Canada, obviously, we have our 4 offices across Canada. Lev had them in the chat earlier, in Vancouver, in Calgary, in Mississauga, and here in Montreal. If you're ever inclined, I invite you to come out, give us a visit. As James was speaking to earlier, it's not just to get to see the machines in person, but we're very happy to sit down with you and talk about ROI and try and find the right machine for you on kind of all levels, not just about what can do the exact application, but what's going to hopefully set you up for success and set your business up to grow. James has some really, great metaphors for this. Robots, farming robots.
Yes.
But we don't want to see you once. We want to see you come in for one laser and grow, and then buy your second laser from us and grow, and then
Yeah. Oh, I see what you mean by farming. Yes. We want to grow you as a healthy tree.
Yes.
We love selling all the materials. We are material sales people as well. So we really want to make you a super successful business with your machine, and it just runs smoothly without fail, so that, hey, maybe we have a chance at selling you new types of material, putting some new tools in your toolbox. And we love doing that, and it'll make you grow even more, which then you buy more material from us. You win, we win. It's all good.
Absolutely. Thank you guys very much once again to everyone in chat. Thank you, the two of you guys, for joining us. Thank you, Lev, in the back end. Again, stay tuned next month. Stay tuned to your emails. If you're not subscribed to our emails yet, I invite you to visit troteclaser.com and get signed up to our emails. You'll be getting all sorts of cool promos and e-blasts and cool kind of special promotions and discounts and things you might not get if you're not subscribed to the emails. But maybe most important, you get to get the private invites to these streams. And next month, as I say, I think it's going to be a good one. So in the meantime, everyone, take care. Be good. We will see you in a month.
See you, everybody.
All the best, everyone.
Bye.
Bye-bye.